Hello guys, welcome back to my channel. I think when I'm seeing this problem and I'm getting a one very thoughtful thing over here that I really want to share, that whenever you are solving a question, there are two perspectives. First, you are reaching to an answer itself, and second, you are making it wrong and getting to know that this particular option why is it here. And I'm thinking like this option is why it is here is kind of thing. But when you solve it and if you get this kind of answer, you will reach to this particular video. If you don't get and you exactly got this answer, then it is good, like your calculation and everything is good. But if you have written the wrong option, like you have get into the trap of the examiner. So let's get started with the question. So body is having a volume V and there is a density which is rho that is attached to a bottom container as shown in the figure. So density of the liquid is greater than the density of the substance. So what will be the constant acceleration and there is a tension in the string. So you have to understand that in this particular type of question, you have to just remember the Newton laws of motion. Like whenever this kind of questions are given, you have to be just do first of all equilibrium condition. You have to pay attention on it. So there is an upward buoyant force that is over the box, or you can say whatever the thing is it, and there is a tension force which is acting downward, and there is a mg which is acting down. So to maintain a equilibrium, you have to do tension plus mg is equal to buoyant force. So what happened that when I do like this particular question, I take it mg, like I didn't change the g into g factor, and that is where I done the question wrong, and this makes my question wrong. When you are taking any acceleration, you have to make sure you are not taking g over here. You have to take g effective everywhere. Then you will get to the right answer. But so yeah, now let's start the question. So tension is equal to buoyant force minus mg, and now I will not write g, I will write g effective. Now whenever I am writing a buoyant force is equal to rho vg minus mg, and that is g effective. Now you again get this g, you have to convert it into g effective. That is the gist of the question. Whenever you are solving an elevator problem, you have to just see, like whenever there is a term of acceleration, you have to eliminate it by the effective acceleration. That is the most important thing whenever you are solving, whether it is a Newton laws of motion question, whether it is a fluid dynamics. All right, so v rho, and the g would be g plus a minus mg. The crux of the question is this g factor, nothing like that. What I done, I took the g factor over here, but I forget to take g factor over here because I was thinking that would be mg only now. Why g factor? But we have to take g factor because the acceleration is upward, and the mass, or you can say the weight, would be also influenced if the acceleration is on upward direction. Alright, so that is the most important thing in this question, and I think now you will able to solve this question very easily. Now what is given? This is given that the density is d, not rho. It is given, it is the d density. You have to take the some things that we call common, like you will take g plus a common. G plus a would be common, and the volume will be also common. Now there will be d minus, when you convert this mass, it will be v into rho. So I convert this rho into d because it is given in the question that the density of the substance is d, not a rho. So I will remove all the rho over here and convert it by d. Now it will be d minus rho because the density of the mass is equal to rho. So v into g plus a into d minus g. This question is as simple as that. I again repeat my point, you have to take g effective whether it is mg. Alright, and then you will be able to solve or crack this question very easily. The option would be 2. Alright, thank you.